Hey, class, this is Mr. Weckesser. I'm going to teach you Chapter 1 today. This is called Patterns and Expressions. And we're learning the basics of algebra today. This is an Algebra 2 class, but the first couple chapters are reviewing algebra. Um, so, patterns, you're going to see shapes today, and you're going to see number patterns. And then you have expressions. And expressions are statements that don't necessarily have an equal sign. Remember, equal signs are equations. So expressions can be seen as, just a basic 2 plus 3, or 2x plus 3, or 2a plus whatever, 2b. There's no equal sign, just expressions. So we're going to go through the notes today, and these notes have answers on them. So you can see the answers while I teach, and you can go through this and review it, fast forward, rewind, as much as you need to figure out um, your speed. Let's hide this down here. Vocabulary. Review. Write the correct word to continue each pattern. So we have just words here: Monday, Wednesday, Friday, Sunday, Tuesday. So we're skipping, and we're going to write when you do patterns. You kind of want to write the pattern down between them. We're skipping one day, right? Or you can say every 2 days, whatever you think the pattern looks like. There's no right or wrong answer for that. So we go Friday to Sunday is another two here, another 2 after this would be Tuesday to Thursday, and you can see the answer right there. Same thing with months. January, we have February, and March we're missing. So now we're missing. Now we're going every 3. April, May, June, we have July, October, January again. So we repeat this pattern, and this is April. So the first one's repeated every 2 weeks. The second one is repeated every year. It goes by threes. Now we have colors: red, blue. We go back to red. So here's the original. And I can even do this in colors for you guys if you like colors. Here's red, red, red. Then we have one blue here. Here's your blue. Then you have a blue here again. And you have a yellow here. So, and there's a red, yellow, blue, and it goes back to that red again. So you see the red right here. And I'll put that in red for you. Then we have shapes, and I like to draw things out. I'm a visual learner. So we have circle, square, triangle, circle, square, and the next one obviously repeats back to a triangle, and here's your triangle right there. Keep going, write the number in each pattern below, and this is more mathematical based now. Now we have to go from 2 to 4 to 6 to 8, and this is just a even numbers, and you're adding 2 every time, so we go to 10. Here we are subtracting, so it's a little different kind of pattern. You go from 6 to 3. How do you get from 6 to 3? So there's a couple ways you can do this. And there's a couple ways you can figure out how to do this, but sometimes people take, for number 5, you would take the second number, subtract it from the first one. And if it doesn't work, you can divide it. So 4 minus 2 is 2. So the pattern is going to be 2 every time. For number 6, you would take 3 minus 6, and you get a negative 3. So the pattern is negative 3 every time. Not necessarily the final answer here, or 10. So you're going down by 3 every time. So this is a minus 3, minus 3, minus 3. And from negative 3, minus 3 is negative 6. So here we're just doing addition and subtraction. So you want to subtract to find the answer. Number 7 is multiplication. In order to find this pattern, you would take that second number and divide it by the first one. So 8 divided by 2, right? Or you can put it in algebra 2. We're going to talk about a lot. You're going to put everything in fraction form. So 8 divided by 2 in algebra 2 looks like this. It's a fraction. And that is going to be a 4. And it's a multiplier by 4. So all these are going up by times 4. And you probably want a calculator when you do these notes. And you want to have access to a web page that I use a lot, not necessarily in chapter 1 and 2, but after that, there's a web page called Desmos. And it should be in the bottom of your Chromebook. You can click on the little sign, it's usually down here. If you click on down here, um, it's a little green button that looks like this up here in the top of the page, and that'll get you to Desmos. And it's a calculator. You can use it as a calculator. You can use it to graph too. You can put in any numbers and push plus or minus, subtract, divide, put parentheses, exponents. It'll do everything for you. We use this a lot, so make sure you get used to this for Algebra 2. So we're going to go back now to our notes. And you're going to multiply by 4. So 4 times 8 is 32, times 4 is 128, times 4 is 512. So hopefully you understand that. First vocab word we're going to have is the word variable. A variable is going to be represented as an X or a Y, most common ones. We also have a Z we use. We also see sometimes an S or a T. An M, we use M for slope. We use H and K in here. We use B for the y-intercept and a K sometimes. So we'll talk about that later on. So a variable is a symbol that represents one or more numbers. You learned that in Algebra 1. Use your vocabulary. Write N if the expression is a numerical expression, and write A if the expression is an algebraic expression. So here we go. 5x is algebraic because it has what it is. There is a variable. Variable is algebraic. So this is a big thing. It has a variable in it. This has no variable number. So this is numerical. This one has a letter, so it's algebraic. This one has another letter or a variable. It's algebraic. So number 9, circle the variables in each algebraic expression below. So you're just circling the variables. Remember, variables are letters. So we have X circled, W circled, D circled, V circled, K circled, and Q circled. Any questions? Okay, let me hide this. I think I tried to do it before. There we go. Next page. Problem 1, identifying the pattern. Look at the figures below from left to right. What is the pattern? Draw the next figure in the pattern. So right here, we have, whoa, I'm not sure what just happened there. Let's go back to black and erase that. So the pattern is every single time, right, there's a black square and you're adding one white square to all 4 corners. So here's 1, and here's 1 again, but you added 1 more on the outside. Now they have 3, so this has 2 on each corner. Now they have 3. So there are 4 white squares in the first figure. There are 4 more white squares in a second figure. So describe the pattern. Remember, there's different ways you can do this too. Each figure increases by 4 white squares. 1 white square is added to the end of each of the shape formed by the existing squares. So in this, when I do these videos, you might have to pause if I'm going too fast, like I said before. So this could be a situation where you pause. Draw the next figure in the pattern. So since the first ones had, this last one had, first one 1, then we had 2, then we had 3. So this next one's going to have 4. They have 4 white squares on each side of the original base black square. Just a pattern. Problem 2, expressing a pattern with algebra. Now we're using the same kind of patterns, and we're going to express it using numbers. How many tiles are in the 25th figure in this pattern? Use a table, and we're going to use tables a lot this year when we do things. And the basic tables we're going to use look like this. They have the input numbers, which is the X value a lot of times. Here are the input numbers. And we're going to use input numbers, the smallest numbers we know possible. So a lot of tables we'll make will look like the one you see there, or they will look like this, just an X and a Y. And you plug in numbers for the X, which is the input, and you get an output, which is right here. Here's the input, there's the output. So the numbers we a lot of times use, unless it's a figure, because there can't be negative. So we a lot of times use the 5 smallest whole numbers, which are -2, -1, 0, 1, and 2. Those are the 5 smallest whole numbers that we use. Again, these are positive negatives. You can't use that with a figure because it's not going to be a negative figure. Not going to be a negative number in a figure. So here you go. We're going to put 1 in for the first one here. And so the process is 2 times 1 plus 1. You get 4. So the first figure, there are 4 tiles, right? The second figure, right, is 6 cut tiles, and you can see it right here. So every single time you're multiplying it plus, right, plus 1 because you have 1 in the first one. So it's really 2, but you have that 1 in the first part. Third one, you have 8, and you can see that here. But they're asking what to do when you have the 25th one, right? Here's the 25th figure they're asking. And that'd be a long process if you had to figure that out. So the process column is 1 plus 2n plus 1 right there, every single time. Number of tiles in the output, you can see here it's 2n plus 2. They just added these two together, this one and this one, to make this 2. So your formula for this, right, your expression is 2n plus 2. So n is the figure, number in the figure. So down here, you can see, scroll down, there are 25 times 2 plus 2. You just use this formula to figure out, oh, the 25th figure times 2, right? We're going to use parentheses a lot this year for multiplication, equals 50. And then you add 2 more each single time, and you get 52. So 52 is the number of tiles in that pattern. Number 16, explain how the table of the values helps you find the number of tiles in the 25th figure. So again, a lot of these problems you'll see in this entire book, the answers may vary. So if you get a different answer, that's okay. It helps me see a pattern to write an expression for finding the number of tiles in any figure in the pattern. So it is true to see a pattern. It helps you. Number 3, using a graph. The graph shows a total cost of platies, right, at an aquarium shop. Use a table to find the cost of 6 platies. I believe this is some kind of fish, a platy is. I'm not really sure. I'm not a science teacher, and I'm not really good with my fish. So they're just trying to find out the number of platies in an aquarium shop, and they have a nice graph here for you, and you have a table. So number 17 says, circle the description of the input value, underline the description of the output value. So the input value is number of platies, and the total cost is going to be the output. So here's our table, right? You can also see it as, here's the X, number of platies, and here's the Y. The X is the number of platies, will keep growing as the total cost grows. So you can see a positive correlation as these both go together. And obviously the next one's going to be right here at 8. So it's just 1 times 2 every time. It's going up by 2. And here's the process, 1 times 2. So 1 input times 2 is 2. 2 inputs times 2 is 4. And you can think, oh, this, so far, Mr. Weckeser, this is very easy. And you are correct. This is very simple so far. A lot of this is review, but like anything in math or anything in life, this gets harder as we go. So 2 platies times 2 is 4, 3 platies times 2 is 6, and so on. And we have 6 platies times 2 is 12. So what is our pattern? It is n times 2, or we like to put the number first, it's 2n. So the question down here says, underline a number or expression to complete each sentence. In the table, when the input value is 6, the output value is what? Well, you could just put that in here, 2n. Put a 6 in here, and you get 12. The expression 2n describes the cost of n platies. N is a number, and you have no idea what that number is, so you say the word n. At the aquarium shop, 6 platies cost $12. And when we do word problems, we like to ask ourselves a question. Does it make sense? Does it make sense to spend $12 on 6 fish? That is a reasonable, does it make sense question. I would say yes, that is reasonable, so that's a reasonable answer. All right, next page. Lesson check. So we're kind of done with this lesson. At the end of each lesson, they have this lesson check, and they want you to do it on your own, and then you check it with the teacher. But unfortunately, this is not possible because you're at home learning or you're by yourself learning. So I'm going to give you the answer, obviously. You just kind of want to check and maybe do it ahead of time when I do these, and then check when I give you the answer. Pause these videos, and then you can see the answer next. But this is how you do it. Make a table to represent each pattern. Use a process column. So here's the table. The inputs, remember, This is 1, 2, 3, 4, and that's just the first number, the second number, the third number, the fourth number. And every time you're going up by 2. So you multiply it by 2. So that's why it's a 2 here, 2 here, 2 here, 2 here. So you're multiplying 2 times the first number equals 2. That's correct. 2 times the second number equals 4. That's correct. 2 times the third number equals 6. And 2 times the fourth number equals 8. So you can see those answers here. And what is our process? Our process is 2n. Here, the same idea. The first set is 1, then 2, and then 3 and 4. That's how you have to think about these. The first set of dashes. So the first set of dashes is 3. So it's 1 times 3 is 1. I'm sorry, 1 times 3 is 3. Then the second set is 6 here. If you counted these are 6, 9, and then 12. So you can see the pattern every single time we're increasing by 1 here, and up here we're increasing by multiplying by 3. So you have 3 times 1, 3 times 2, 3 times 3, 3 times 4, and our pattern is going to be 3n. And lesson check, the last part, do you understand? And again, this is supposed to be for yourself to self-check, to regulate what you do know, what you did not know. If you have problems with this, you email me or call me, and I can help you with this to see if you actually understood the lesson. Your friend looks like for a pattern in the table at the right and claims that the output equals the input divided by 2. So the output equals the input divided by 2. Is your friend correct? Explain. Well, right away, the first two numbers. Is that divided by 2? No. So this is not correct right away. This divided by this does equal 2. Yes, yes, and yes. But the first one is wrong. So it cannot be correct because everything else is correct except for the first one. Circle the rule that applies to most of the input and output values. Most of them is the key word here. We're going to say this: output equals input divided by 2. Does the input value of 3 follow this rule? Here's the input value of 3. We're going to say no. We've already said no up there. Does the table represent a pattern? Explain. And again, answers will vary. Whatever you put could or could not be interpreted as correct. No, the input of value of 3 corresponds to the output value of 2, which does not follow the same rule as input and output value. You could write all that down, or you could just do like this: 3 divided by 2 equals 1.5, which does not equal 2. Math success. And again, this is what the vocabulary you know. You're supposed to check these words off if you know the definitions, the 2 definitions we learned today, and then you rate how well you can determine the patterns. You can just rate it and say, okay, I maybe learned 8. Then you're going to stop after this lesson and you're going to do the homework, which is a couple questions, up 5 to 10 usually, and then the quiz for this chapter, which is also 5 to 10. And you're going to let us know how you did. So if you have any questions, please email Mr. Weckesser at any time, and we're going to help you from there. It might take me a while to how to pause this first video here. I apologize.